So today we're doing the second part of factor by grouping. So factor by grouping, yesterday we used it to factor quadratic trinomials, and I kept the problems to problems that did not already have a greatest common factor in them. But today we're going to look at some that do have a greatest common factor that we have to take out before we do any of the other grouping work. So here we go. Here's our first example. It says 6x squared plus 10x plus 4. Our first step, you'll notice that all three of the terms that are there have a 2 as a common factor. So our first step would be to factor out a 2. And so I put the 2 that's factored out on the outside of the parentheses here. And then I divide each of these terms by 2 to give me the other factor on the inside. Now, once I've done that, then I'm going to focus on the inside parentheses here for factoring, and I'm going to do everything that we did yesterday. So we would take the first term and the third term and multiply them together, and we get that product, a positive 6x squared. Then we'll make a list of factor pairs for 6x squared and sum them. And the sum we're looking for is the number that is the middle term, the second term inside the parentheses. So after we've already taken out that greatest common factor. So this is the pair that works for that one. So if I then use that to split up the middle term, just like I did yesterday, then I can make the two groups, and the entire process is the same from there. The only thing that's different today is that greatest common factor that we took out originally is going to keep getting brought along with each and every step. So there's going to be a 2 and big parentheses around the whole thing in every single step, all the way down to the very bottom. So this very last step, the extra set of parentheses could then finally be dropped. I forgot to put that on the notes. I'm sorry. We'll do that in the examples. Alrighty, so here we go. We're going to factor each of these trinomials. The first thing we're going to look for is a greatest common factor. So I'm looking at the three terms that are here. I have coefficients on all three terms, and I note that all three of them are even numbers. So I know for sure they're at least divisible by 2. 8 and 12 are divisible by 4, but 22 is not divisible by 4. So 2 is going to be our greatest common numeric factor. Now I'm going to look at the variables as well. So I notice in all three terms there are y's. And in fact, in all three terms, there's a y squared. So I'm going to have a y squared as my variable greatest common factor. Now I'll take each of these terms and I'm going to divide them by 2y squared. So 8x squared y squared divided by 2y squared would be 4x squared. 22xy squared divided by 2y squared. 22 divided by 2 is 11. And the y squareds cancel each other out, so that just leaves x for the variable. And then the third term, 12y squared divided by 2y squared. Again, the y squareds are just going to cancel each other out. 12 divided by 2 is 6. Okay, so from here, I'm focused just on the inside part, but my greatest common factor that I took out originally is going to have to keep getting brought down with every step that I do here. So I'm going to go ahead and write it down right now so I don't have a chance to forget it. I'm going to multiply together 4x squared and 6, and that would give me 24x squared. That's a positive 24x squared. So I'm going to start making lists of factor pairs for this one. So I could have 1x and 24x. And if I add those together, I would get 25x. And I could have 2x and 12x. And that would give me 14x if I add them together. Now remember, we're trying to get this number in the middle, this negative 11x. So once I come up with something that looks like it's going to help, I'm going to stop and use that. So I've got 3x times 8x would be 24x squared, and 3x plus 8x would be 11x. Okay, so now I think I'm getting pretty close here, as I need a negative 11 and I got a positive 11. So if I were to make both of these negative, when I multiply them together, negative 3x times negative 8x, I would still get a positive 24x. But when I add them together, then I would get that negative 11x. So I'm going to go ahead and stop right there. I'm going to replace my middle term, my minus 11x, with minus 3x plus minus 8x. So now I'm just recopying the first term. The middle term is now going to be replaced with minus 3x plus minus 8x. And now I've got my 4 terms there. I've got the plus sign in the middle that is necessary for this method to work here. So I'm going to go ahead and put in my parentheses. And then before I do the next step, I'm going to bring down that original greatest common factor so I don't have a chance to forget it. Now in the first grouping, I'm looking for the greatest common factor for just these two. 4 and 3 don't have anything in common besides a 1, but the x squared and the x have an x in common. Remember, when you're taking out a greatest common variable factor, you're taking out that variable with the smallest exponent of any of them that are there. So 1 would be the smallest exponent there. So divide each of those terms by x, we would get 4x minus 3. And in the second group, negative 8 and positive 6, they have a negative 2 in common, taking out a negative because the first term was negative. So negative 8x divided by negative 2 would be positive 4x, and 6 divided by negative 2 would be negative 3. All right, now factor by grouping only works if after you've taken out the greatest common factor from each of your small groups, the two things that are in parentheses are identical, and they are in this case. So now I'm going to take the common binomial factor out from these two larger terms, so to speak. And again, that original greatest common factor, I'm just carrying it along with every single step. So now I'm taking out the common binomial factor, 4x minus 3. And when I divide each of these terms by 4x minus 3, what I'm left with is x plus negative 2, which I can just write as x minus 2. And this is now factored. Okay, so we have a second one on here. If you're feeling pretty good about this, this would be a good time to pause the video and give this one a shot. And if then you can come back and see how you did. All right, so once again, we're going to look for greatest common factor. One thing that jumps out at me right away is that all three of these numbers end in either 5 or 0. So I know for sure they're all divisible by 5. After a quick inspection, I can see that they have no other numerical factors. So I'm just going to put a 5 in the front there. As far as variables, they all have x's in them. So there is definitely going to be a variable common factor. The smallest power of x in any of those terms is a 1. So x to the first power would be what we factor out. Okay, so now I take each of these terms and I divide them by 5x. So 25x cubed divided by 5x would be 5x squared. 70x squared divided by 5x would be, let's see, 5 goes into 70 14 times. And then 15x divided by 5x would be 3. All right, so now I'm working on the inside part here. I'm going to start by multiplying together 5x squared and negative 3, and that would give me a negative 15x squared. And I'm going to work on factor pairs that'll multiply to make a negative 15x squared and add to make this number in the middle, negative 14x. So I think I'm going to start with 1x and negative 15x. So if I add together 1x and negative 15x, I get negative 14x. So already I found the pair that's going to work, and I don't need to keep going with this list. So now I'm going to go ahead and copy down that greatest common factor again. And then I'm going to use these numbers that I found on the side in order to break up my trinomial, or sorry, break up my second term of my trinomial factor here. So this would be plus 1x. I'm just going to write plus x, and then plus negative 15x. My plus sign came out looking like a T. There we go. And my x looked Greek. And then the last term is a minus 3. Once I've broken up that middle term and I have a plus sign in the middle, I can group together the first two terms and the last two terms. And then I'm looking for the greatest common factor in each of those groupings. The very first thing I'm going to do, though, is, again, bring down that original greatest common factor so I don't have a chance to lose track of it. And the first grouping, the two terms have an x in common. So I divide each of them by x, and my binomial factor there would be 5x plus 1. My second group, the greatest common factor would be a negative 3. Again, we're going to take out a negative because the first term of the binomial here is negative. So I'm just taking out a negative to deal with that. So negative 15x divided by negative 3 would be 5x. Negative 3 divided by negative 3 would be a positive 1. Now, once again, factor by grouping only works if these two binomial factors are identical, and they are. So that's going to be a common binomial factor for these two larger terms. Once again, I'm going to bring down the original greatest common factor. My next step is to take out that common binomial factor from the two terms on the inside there. So I'm pulling out the 5x plus 1. When I do that, I have to divide each of these big terms by 5x plus 1. So that would give me x plus negative 3. I'm just going to write that as x minus 3. And this one is now factored also. Okay, if we have a polynomial that has 4 terms already, we can use factor by grouping for this one also. Once again, you still look for a greatest common factor first. So here I've got a polynomial with 4 terms. This one will be a cubic polynomial with 4 terms. There is a greatest common factor. All of the numeric values here are all even. So 2 would be a common factor for all of them. So factor out a 2. And then we can use grouping still. Again, you have to have that plus sign in the middle. If there's not a plus sign when you start the problem, I'm going to show you how to make one happen there. So group the two things. Keep bringing down the greatest common factor each time. Take out the greatest common factor for this grouping and the greatest common factor for this grouping. Now 4x and 1 only have a 1 in common, so I wrote down a 1 there. Now the two binomials do match, so that means factor by grouping is working. And so I'm taking out that 4x minus 1 common binomial factor from each of these two larger terms. And that would leave me, when I divide each of them by 4x minus 1, that would leave me with 3x squared plus 1. So this would be my fully factored form here. Now with this one, particularly when you're dealing with cubics or quartics or anything of a higher degree polynomial, you do need to check your factors then to see if they can factor any further. Like this one here is still quadratic, so there's a possibility it could factor further. In this case, it does not. All right, so now we're going to try factor by grouping for this cubic polynomial with 4 terms. I think I want a different color now. Let's go with red. All right, so it does have 4 terms. I'm looking for a greatest common factor first. The numeric values 2, 5, 6, and 15, all 4 of them do not have anything in common. And there are x's in 3 of the terms, but not the 4th one, so they don't have an x in common either. So no greatest common factor amongst the 4 of them. So I'm just going to start with grouping, keeping in mind it does have to have a plus sign between the two groups. Now in the first grouping, our greatest common factor is x squared. So I'm going to take that out of just that group. That would give me 2x plus 5. The second group, the greatest common factor is 3. When I factor that out, divide that out from each of those terms, I would also get 2x plus 5. So the binomials match. So that means these two big terms here have a common binomial factor. So I'll be taking out that common binomial factor, 2x plus 5. And when I divide each of these terms by 2x plus 5, I end up with x squared plus 3. And I wanted to emphasize again here that each of these factors need to be in their own set of parentheses. You can't just drop the parentheses and say that it's all the same. This one is quadratic still, so we would check to see if it factors any further, but x squared plus 3 does not factor anymore. So this is done. I'm going to do this one down here with you and leave the other two for you to try. I think we'll go green this time. Okay, so for this one down here, looking at all 4 of the terms that are there, 12, 28, 15, and 35, all 4 of them do not have any factors in common. There's an xy in this term, but no y here, no x there, and neither of the variables over here. So they don't have any variables in common either. So no greatest common factor. But this one does have a minus sign in the middle of the problem. So before I can group, I have to turn that minus sign into a plus sign. So I'm going to do that by just putting a plus sign there. And it still has to say minus 15y, so I'm just going to fix it by saying plus a negative 15y. That now gives me the plus sign in between, so I can group together the first 2 terms and group together the last 2 terms. Now I'm looking for greatest common factor in the first grouping here. So 12 and 28 are both divisible by 4. And x exists in both of those terms, so 4x would be my greatest common factor there. So I divide each of these by 4x, that would give me 3y minus 28x divided by 4x would be 7. My second grouping, 15 and 35 have a 5 in common, so I'd be taking out a negative 5 since the first term of this binomial is negative. When I divide negative 15y by negative 5, I would get 3y. And 35 divided by negative 5 would be negative 7. Okay, now I need to see if factor by grouping is working. And it only works if the binomials that you come up with here are the same, and they are. So that's going to be our common binomial factor for these 2 big terms. So I'm going to take out a 3y minus 7 from both of them. When I divide each of those things by 3y minus 7, I get 4x plus a negative 5, which I'm just going to write as minus 5. And this one is now done. Okay, so you try the other 2 on there. You can pause the video here and then come back and check and see how you did.